Hello! Hello, everybody! Welcome to the LIUniverse. I'm Dr. Charles Liu, your host, and of course, you really do need to call me Chuck. With me, as always, is our wonderful co host, Allen Liu. Hey, Alan, how's it going?
Hi, it's going good.
Good. Considered any decision tree algorithms lately?
I was trying to come up with something about. It's not exactly a decision tree algorithm, but it does have to do with directed graphs.
Oh,
About how to arrange smaller photos into one big mosaic.
huh.
I don't know. It's an interesting math problem.
Yeah. Well, did you come up with a solution?
I came up with some lower bounds that are like already in the factorial range, so it's kind of a mess.
Okay. All right. Enough geeking out for now.
Yeah.
That's wonderful stuff. I'm really looking forward to your results on that one, Alan. It's terrific. Yes, we can't geek out too much before we introduce our wonderful guest, Dr. Nicki Driscoll. Hello, Nicki. Hi.
Hi, thanks for having me on the podcast.
Oh, it is our pleasure to have you. You are very cool. Uh, you have been at Brown, and then you went to Penn, and then you did postdoctoral work at MIT, and now you are the co-founder and chief technology officer of your own very cool company.
Yeah, it's been quite a journey so far.
Oh, you got to tell us about this company. It is called what?
Neurobionics.
Neurobionics. Oh yeah, I'm thinking $6 million man. I'm thinking telepathic cybernetics. Oh, this is amazing stuff. But of course, I know there's a little bit more actual science involved than fiction. But it is very neat, and it's totally down the path of the kinds of things we want to talk about. So we can't wait to have you. Thank you so much,
Awesome.
Nikki.
Yeah, can't wait to nerd out about it.
So let's first start, as we often do, with today's joyfully cool cosmic thing of the day. Now, Alan, did I get the order right this time?
Yeah, except sometimes there isn't an of the day because it's sort of already implied that it's of the
Oh,
day.
that's
So it's
true.
today's, but you got the
That's
order
true.
correct.
Okay, so it's today's joyfully cool cosmic thing, and it is indeed cosmically cool. It is the discovery recently announced of a super Earth that is within its star's habitable zone. Now, what does that mean exactly? A super Earth is just a really big planet that's like Earth, but just bigger than Earth. And it's not a gas giant or some other structurally different one, but it's a planet that's like Earth. So this planet is discovered. It was 1.5 times roughly the diameter of Earth. And it orbits a red dwarf star, an M4 star, 137 light years away. Now, 137 light years does seem like a lot, but of course, considering that our Milky Way galaxy is more than 100,000 light years across, 137 light years is just a stone's throw, a
It's not
mere,
too bad.
yeah,
Our cosmic
700.
backyard.
That's right. That's right. If I'm not careful, I might accidentally throw a ball over the fence and land in this planet backyard. So I'm really excited because it is apparently in a zone near this dwarf star where liquid water could exist and be stable on the surface of this planet under the right atmospheric conditions. And as we know here on Earth, it is that water conditions, one of the three critical conditions that allow us to have life on Earth as we know it, and even intelligent life as we know it. So I'm really psyched to talk about the possibility, the real scientific search for extraterrestrial intelligence, which must, of course, start with our own brains. What is intelligence? What does it actually mean? And what do our brains do? Right? Nikki, why don't you launch us on this conversation, right? The very basics of what it means to have a brain, to have intelligence, and to be able to think about extraterrestrial intelligence as an abstract thing and not just like as little creatures walking around.
Yeah, I mean, it's so incredible that we have become advanced enough and our brains are advanced enough that we are at a point where we can think about what is out there and really think out into the universe and really wonder if there's other intelligent life out there. Um,
Yeah.
and really, our brains are kind of their own little universes. They're incredibly complex. What makes you who you are is just the sum of this really complex interaction between different neurons that are firing at different rates and they have different connection patterns. So it's really just this incredibly complex and a little bit stochastic activity in your brain that gives rise to everything that makes you who you are, and all of your thoughts and dreams and hopes. And so it's really incredible to think that like this little 3 pounds of wetware in your head gives rise
Yeah.
to consciousness and
Yeah.
the ability
Oh
to
man.
ponder the universe and whether or not there is intelligent life elsewhere. So I love the brain. I think it is incredibly fascinating, and I've always been really drawn to the fact that there's still so much we don't quite know and understand about the brain, which is one of the reasons that I was so interested in studying the brain and trying to understand it better.
Yeah.
Because as exciting as it is to ponder the universe and what's out there, it's incredible how much we still don't quite understand about what's in here,
Yeah.
and especially when we think about when things go wrong in the brain, like neurological disorders and
Ooh.
injuries. There's a lot we still don't quite understand about what underlies those different conditions. And that prevents us from coming up with better treatments. And so that
That's
was
a
one of my
great
main motivations to go into studying the brain.
That makes total sense. You had mentioned stochastic processes in there. For those of us who aren't exactly, keyed in on that randomness or that disorderly concept of stochastic processes, give us a little bit of context about how many neurons are in a typical human brain, and about how many connections per neuron are there from that each neuron all throughout the brain. I mean, just how much is it?
Yeah, I mean, there is over 1 billion neurons in your brain, and each neuron can have thousands of connections, which are synapses with other neurons. And each one of those connections has some inherent variability. And what's really cool is each individual neuron behaves almost like its own little computer or computing sort of node, because each neuron receives synaptic input from many, many other cells, and that neuron decides whether or not it's going to turn on or fire an action potential by sort of integrating input from all these other neurons. So there's this sort of like summation, almost mathematics, that's going on in an individual neuron that tells it whether or not it's going to fire. And this is going on across trillions of synapses in your brain, which is just absolutely incredible. And that's what gives rise to
Yeah,
this like amazing amount of complexity.
wonderful.
I'm a big fan of the math that goes into studying the brain. I mean, there's a paper or something that I was reading, maybe just an article in some science magazine that was talking about the neurons form a small world network, which is a math graph theory concept where it's like there's only it's so if you imagine like a big grid,
Mm,
and those connections are only on the adjacent lines of the grid, then getting from one end of this grid to the other, you have to go through lots of little steps. But if you
right.
have something like the brain or these small world networks that these where people were talking about, you have a few connections that go like all the way from one side to the other. And that means
Oh,
it only takes a few steps to actually get from any neuron to any other neuron.
so not only do you have little towns and villages along the streets and roads, you also have these interstate highways that just zap all the way across the brain incredibly quickly. Wow.
Yeah. So if you've ever looked at a picture of the brain or an MRI scan, you might notice that there's areas that appear more white and areas that appear more gray. And we call those white
Mm.
matter and gray matter very creatively. And
Well, it's
the
like the
white
answer is
matter.
with the black holes.
Yeah,
Exactly, exactly. The white matter is actually those highways that you were talking about. So
oh,
the white matter are bundles of axons, so basically individual neuron projections that are going very, very far across the
mhm.
brain. So those
Wow.
white matter areas are basically the superhighways of information traveling long distances. And in that
Ooh.
gray matter area, you have a lot more very small local connections between cells that are close to one another. So
Oh,
there's, yes, there's
wow.
that combination.
Huh. Is it a coincidence? I mean, just that somehow our way of designing highways in the United States on this very macro level wound up mimicking the like microscopic or human sort of scale of how our brains work. Is it just a universal reality that we wind up heading toward these particular systems, or is it just coincidence, you think?
You know, that's such an interesting question. I think one of the most interesting things is nature, and everything that we have evolved to be has happened through a lot of random mutations, and I
Mm.
think that what that has given rise to is biology, and nature has found a way to create these incredibly efficient systems.
Hmm.
somewhat by accident, but because efficiency is an advantage. And so that gets
Right. Yeah.
selected for over millennia through natural selection. And
Hmm.
so much in nature and biology is just incredibly, incredibly efficient. And I think it's
Wow.
really interesting when we think about designing things in our world, like highway systems. When we try to make the most efficient system, sometimes it does end up looking a lot like something from biology because it turns
Ha.
out biology has done a really good job at finding efficient ways to make things work.
Yeah,
Wow.
that reminds me of another thing where it was like slime molds ended up recreating the Tokyo subway network or something like that.
Wow.
Because yeah, it's like what you're talking about. It's the kinds of solutions that biology finds end up being the same kinds of solutions that work in a lot of situations. So we would want to keep using them in our own artificial things.
Yeah. And if I think about the large scale structure of the universe, the kinds of maps that we astronomers have been making over the decades about where the galaxies are spaced out, you find something that really looks like a network, both superhighways and little tiny filaments and things like that. And you look at cosmic background radiation combined with the large scale structure of dark matter. It looks like a brain. It looks like a whole bunch of neurons attached with a whole bunch of synapses. I think it's neat that it's coincidental, but also neat that there is this convergence in nature and just how things kind of work together. I think that's super cool. Um,
Absolutely.
Alan, do we have a question from the audience that we could just give Nikki right now to answer?
Yeah, sure. So we're going to start off with a question from Madison H, who is asking, "What is the most interesting thing about the human brain that impacts the way humans think?"
Hmm.
Wow, Madison, that is a fantastic question. Oh man, there are so many ways to answer this question.
Pick one.
I think, yeah, 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 yeah. I'm trying to think of like the most. I think one thing that I find so fascinating about the brain is that it has evolved to use all these different mechanisms to signal. So the way that you are thinking has to do with electrical signals in the brain. So neurons that are
Hmm.
actually sending little currents and electrical impulses to one another. But there's also chemical signaling that plays an extremely important role. And these are the neurotransmitters and chemicals in your brain. And
Mhm.
what's incredibly interesting, I think, is that we're starting to learn more and more the role that these different neurotransmitter and chemical agents have in the way that we think. And, I think that there's been a big rise in push towards doing research and understanding mental health disorders like depression
Mhm.
and
Yeah.
having an understanding that a lot of what causes these disordered thinking in the brain comes from different imbalances in these chemicals. And I think
Oh,
that's just incredibly fascinating that some, slight difference in how your serotonin behaves versus my serotonin might affect how I feel from a day-to-day basis. And so yeah, it's amazing what the little tiny chemical messengers can really impact the way that you think.
that is so cool. Two identical brains could have completely different situations if their chemical balances or imbalances are different. Wow.
Or even the same brain at
Yeah,
different times.
Same
exactly.
at different
Yeah.
times too, really? Wow, that makes total sense, but at the same time, that's kind of a little frightening. That like today, my perfectly normal brain under this circumstance, and then tomorrow, my perfectly abnormal brain under this other circumstance.
It's
Wow.
true. I mean, your brain can go through these different states from different events in your life that might trigger something like that, and then you might be stuck in a down state for a while. So, one thing that I've really feel passionate about is for a very long time there was so much stigma surrounding mental health, and I think a lot of that was we just did not understand what was going on. And
Mm.
now we
Ah.
have a much clearer, we still don't understand these conditions fully, but we have a much clearer understanding that there's a biological basis. There is
Mhm.
a something that underpins why someone who is depressed feels that way, and it's something that we can are starting to develop ways to treat better. But
Wonderful.
just having a basic understanding that this is something in biology and it's not, it's something to be ostracized or looked down upon.
Yeah, that makes so much sense. I think of, for example, Jane Eyre or something, Victorian times where people with mental illnesses were literally locked up and chained because they were either an embarrassment or a frightening creatures or whatever. And now we know that that's
Yeah,
completely untrue. And I'm really glad that we're getting even closer to legitimate, rational, scientific ways of dealing with what otherwise has been very difficult over the history of humans.
I have a related tangent, which is that epilepsy, way back in ancient times, humans have had
Right.
epilepsy for as long as we've had humans. And
Hmm.
back in the day, even back into like ancient Egyptians, I think, they thought that people with epilepsy were possessed by devils. So
Oh,
this was the stigma that surrounded because someone would lose consciousness and shake, and we had no way of understanding what was causing that. So
wow.
it just kind of goes to show this crazy, stigma that can come up around these conditions when we don't understand what's going on.
Hmm.
Yeah, it's absolutely wild.
Wow. Well, tell us a little bit about Neurobionics. What is it that you guys are doing that's like above and beyond all the other cool stuff that's out there? I mean, there's recently an announcement from some company by some, reasonably well-known CEO type person of some random company that they had put some brain implant into somebody's head, and it was all very exciting and whatnot. And, you know, I'm perfectly excited about that too. But I bet you're actually doing things that are uh, pushing the boundaries in different ways that are even cooler and really fun to do.
Yeah. Happy to chat about this. So I work in this field called neurotechnologies. My background, I come from an engineering background, but I've always kind of applied engineering to neuroscience and studying the brain. And my
Mhm.
sweet spot has been in developing devices that allow us to interact with the brain, both recording and
Wow.
maybe even stimulating activity in the brain. And
Ooh.
so there's kind of, none of these have neat lines, but you can sort of lump neurotechnology into maybe two big buckets, and they kind
Uh-huh.
of differentiate across. One part of them is like recording neural activity, and those are
Hmm.
what we typically think of or call brain computer interfaces. And in that
Ooh.
field, the idea is to put electrodes in the brain, record the activity of those neurons, and then use that, try to decode that activity and use it to help someone who maybe has paralysis or is unable to communicate. And
Wow.
so those kind of new bounds brain computer interfaces are what's really taking the news by storm these days. There's been a
Mm.
lot of development in recent years, which has been incredibly exciting. And yes, as you mentioned, one thing that's very much been in the news is Elon Musk was involved in starting a company called Neuralink a number of years ago, and they just
Uh-huh.
had their first in human demonstration, which is incredibly exciting for the whole field of
Wow.
neurotechnology.
Wonderful.
And yeah, as you know, problematic as Elon Musk can be, Neuralink has accomplished really great things. And so it's
That's
very
good.
exciting to see all the kind of attention that they've brought to the field.
Yeah.
So that's brain computer interface, which is essentially
Uh-huh.
recording activity. And then there's
Hmm.
sort of this other category, which is the flip side. Instead of recording neural activity, let's actually stimulate and send some signals into the brain. And this
Aha.
is something called neuromodulation. So, actually trying to modulate or affect activity in the brain. And this is typically used as a therapy. So,
Mhm.
there are different conditions by which stimulating in the brain can actually help a lot. And uh, an example of that is a therapy called deep brain stimulation, or
Okay.
DBS. And what that's most commonly used for is Parkinson's disease, essential tremor, and epilepsy.
Aha.
And
Oh.
essentially, what you do is you have a brain surgery and you place these rods of electrodes into these specific deep brain regions and you
Whoa.
stimulate there. And it
Whoa.
sounds really crazy, but what that's
Yeah.
able
Yeah.
to do is it actually helps these patients a lot with their symptoms, especially
Wow.
Parkinson's and tremor, where they tend to have these uncontrollable tremors and inability to control their body very cleanly. What stimulating these brain regions can do can really minimize the tremor and help them regain more control over
Wow.
their bodies. And
That's really
so
That is
it's
cool.
absolutely incredible. This therapy works super well. Yeah. But the big downside is you need to have this very invasive brain surgery to have
Yeah,
these
yeah.
electrodes
Big
implanted.
fan.
And then you have a wire that kind of goes under your skin to a unit that sits in the chest that has the battery and the electronics. So
Yikes.
super cool therapy, but very, very invasive and scary surgery.
Okay.
And
Yeah.
this is a long intro to talk about what we're doing at
Yeah,
Neurobionics.
I loved it. That was a
All right.
wonderful intro. Heck, if we had had deep brain stimulation back in the day when people thought epileptics were demons or demon possessed, then in fact they wouldn't have that problem, right? They'd just have stuff sticking out of their heads and so forth. And I don't know, maybe they would have been more like Frankenstein's monster, but but
Yeah, I'm
nevertheless,
not sure we had the
no,
right surgical techniques back then, but
yeah.
Yeah,
You know,
they
little
were
screws sticking out
children
of your
of
forehead.
trepiding at that point, right? So,
yeah.
Wow. But your work is in this area then to make it
Yeah.
better.
So, yeah, our goal at Neurobionics is essentially to deliver the same therapy, stimulation in deep brain regions, but do it with a technology that allows us to get there without doing brain surgery. And the way that that
Whoa.
works, yeah, we actually have these like very thin fiber devices. These are like
Mhm.
as thin as a human hair, but we've got electrodes in there. And what we do is we can navigate into the brain through what's called an endovascular approach. So basically, snake a catheter in through your blood vessels
Man.
and deliver a device out of this catheter into your brain, which sounds very
Wow.
crazy.
It
And
does.
that sounds crazy.
yeah, we're
It
That's
sounds like this
kind
will
amazing.
of
help a lot of people too.
yeah. So what some people may not be aware is that surgeons are actually already very, very good at navigating catheters to the brain. They do that
Mm.
today to treat stroke. So
Oh,
typically,
huh.
when someone comes into an ER with stroke, they're
Mhm.
rushed to a cath lab or catheterization lab, and they
Uh-huh.
essentially take a catheter and snake it up into their brain and then suck out the clot to restore blood flow. So
Oh, okay.
Amazing.
it's wild, yeah. So
Wow.
there's already this whole field of medicine and clinicians who are really good at navigating catheters into the brain and getting where they need to go. And what we're doing is basically just developing a tiny device that can piggyback on that approach and get delivered
Mhm.
through the catheter into the brain and deliver stimulation that way. So that's the big vision with neurobionics.
That is fantastic. I'm amazed. Alan, do we have another question for Nikki?
Yeah, we've got a question from Aline who is considering getting a PhD. And Aline's question is about that. So, since you have your PhD, do you think it was worth it or gratifying going through that many years of schooling?
Yeah, that's a really good question. I think I for me it was absolutely worthwhile and I enjoyed that process so much. Um it really depends what you want to get out of it and what your career goals are. I think a PhD is an opportunity to really dig deep in understanding something very deeply and becoming the foremost expert on something because by nature doing a PhD means you're researching something new, you're researching something unknown, and therefore you're going
Mm,
to know more about that than anyone else. So if you really enjoy kind of hard questions and pushing yourself to learn new things, a PhD can be incredibly rewarding. Um, it also depends somewhat on your career goals, though, because it is a long time to go to a PhD. It's a significant portion of your life, and so you just have to make sure that it's kind of helping you towards what your ultimate goal and vision is.
Hmm.
But yeah, it's a long journey. If it's something that you're really passionate about and enjoy learning about, then it can definitely be worthwhile.
makes a
Great
lot of
question.
sense.
Yeah, and great answer, Nikki. You're right. You know, you are the world's leading expert in your area of expertise, aren't you?
In a very niche thing, yes, that I spent my PhD on.
Makes a lot of sense. Yeah, so Elaine also has an additional question, which is a little bit on a slightly different topic. And
Hmm.
this question is: do you think AI will ever reach a point where it will start dangerously affecting our day to day life, such as job opportunities?
Hmm.
Wow, that's a great question. I think that's a question a lot of people are trying to answer right now. So
Yes.
very timely.
Yeah. Yeah.
um,
In all my classes too. Yeah, I'm
oh,
doing that. I'm
absolutely.
making sure that
Yeah.
every student understands how important AI is. Of course, astronomers have been using AI and machine learning for decades now to try to do some of our astronomy in very lame baby steps. But we've really reached a different point now where, like a brain expert, like an intelligence expert, is really needed to assess where we are now, I think. What do you think, Nikki? Yeah.
Yeah. I mean, oh, it's such a good question. I think, yeah, AI in various forms, machine learning algorithms, not necessarily the same thing as AI, but have been incredibly useful and have started to really transform so many aspects of our everyday life. And I think this became very tangible and real recently with the advent of ChatGPT and software
Mhm.
that can generate images that you ask it to,
Right.
and the rise of deepfakes. And
Ugh.
I think, will it reach a point where it starts dangerously affecting our day to day life? Honestly, I think the thing that worries me the most about AI is its ability to generate fake content and
Oh.
society's growing inability to distinguish fact from fiction. So, honestly, the
Uh-oh.
thing that scares me the most about AI is the rise of these so called deepfakes and the ability to generate misinformation that can be much harder to now determine if this is true, or did an AI generate this image or generate this, snippet of someone speaking, but they never actually said that. Um,
Wow.
that said, I think there's a
Mhm.
lot to worry about with AI, but I think there's also a tremendous amount of promise for what it can really do for us.
Mhm.
We're already seeing how much tools like ChatGPT can enhance productivity, help people be better writers, help people tailor their job applications. So I think it's a mixed bag. There's certainly fears and things that it could do quite badly for society, but there's also so much hope and so much potential for what AI could do to make our society better. um, I think there's a lot of unknown questions right now, sort of which of those will win out, like the good or the bad, and some of that has to do with our ability to kind of restrain ourselves from using these tools for nefarious purposes, and regulating them efficiently.
Wow. That
Yeah,
that reminds me so much of conversations back when we were kids. Well, when I was a little child, about nuclear power and the idea that there were a lot of things to be afraid of, but there's also tremendous potential. And we see it today in everything from generating power without emissions to things like nuclear medicine and lots of neat technologies. Maybe nuclear power will help get us into the rest of the solar system through spacecraft and things like that. So, so far, we have been able to control ourselves as a society in using nuclear stuff for good and not too much ill. Uh, is your sense, Nikki, that AI is sort of in that same boat where most likely we're going to be using it for good, and most likely we'll be able to control it for to protect against these negative things, at least for a few decades?
I think so. I tend to be an optimist in general, and I think that on balance, AI is going to do so much more good for the world than harm. So there's certainly these risks, but I tend to think the benefits that we'll get from AI will outweigh the negatives, definitely.
Hmm,
And
that's
we've
good.
seen this again and again. Every time we have a new disruptive technology that we don't quite understand that well yet, there is always this backlash and this fear. And so many times it ends up being a net positive for society. So let's just hope that this goes the same way.
Yeah,
yeah. Well,
I
we
mean,
can help, but we can also work on it. You know, we can try and set things up so that we have the regulations in place, like you were mentioning, or we have the standards and the kinds of things to ensure that we know how to use these tools correctly, and that they're not gonna go beyond the control of people who are trying to use them in a proper way. You know.
excellent point.
Absolutely.
Excellent point, Alan. Um, it's been discussed a lot in fiction too, right? Speculative ideas, sci-fi about artificial intelligence. Um, I love seeing some of the old TV shows and movies about what they thought artificial intelligence was like, right? Everything from HAL on 2001: Space
Yeah.
Odyssey. Um, do you remember the AI called Iraq on Wonder Woman?
I do not remember that one.
Oh, I don't
Oh
know that
yeah.
one.
Ah, see, there's just so much
See,
of
my
that
era of
going on.
people is talking about like Gladys from Portal. So
Portal,
Yeah.
right?
and
and,
Wheatley,
and
the dumb AI on built on purpose to make the smart AI hampered by having to deal with it.
oh man, yeah.
Wow,
So these
yeah.
kinds of funny things, but far
Yeah.
fiction, way beyond. There's stuff like AIs that are galactic and cosmic in scale, right?
Yeah, I was actually just reading a really interesting series. The first book
Oh,
of that series is called Children of Time, and it has some good parallels to the conversation we're having, which is both
ooh,
brain science, brain computer interface, and AI. So
uh-huh.
All
one
right.
of the major plot points and characters in this book, and this character stays throughout the rest of the series, is essentially to I should back up and give the backstory. So
Yeah, totally.
this book, it takes place in the future when we are
Okay.
a space faring intergalactic culture, and essentially
Ooh,
humans have gone out to terraform other planets because we've mostly ruined Earth at this point. Um, and so we send
bummer.
out these missions to terraform other planets, and then the society on Earth essentially collapses and sends out this
Ooh,
computer virus to wipe out all of the other humans that are out in space. And
what? That's not
one of
very
these
nice.
people, I know, yeah, but one of these terraformers actually survives by uploading her consciousness into a computer and becoming this like human AI hybrid, which is
Wow.
totally crazy.
Ooh.
However, I've told you I work in neurotechnology,
Yes,
and
Yeah.
so there's been a lot
completely.
of questions from people over the years about
Yeah.
like, oh, could I upload my consciousness to a computer someday? I will tell you, I don't have an answer to that. We will
Wow.
not be able to do that anytime soon.
Okay.
We are definitely not there yet with
Yeah.
our
Yeah.
Right.
understanding of the brain and our ability to tap into the complexity of the brain. But it's very fun as part of
Yeah.
a plot point in sci-fi to think about like,
Wow.
what would it look like if you were able to put your person in a computer, essentially? So
Yeah.
Yeah. I
yeah,
remember
it's a fun
reading some of
parallel.
the. I remember reading
Yeah.
some of the state of this kind of thing, and they're like trying to. We're still working on like C. elegans brains, which are not even brains; they're just like 203 neurons or whatever, 302
Right.
neurons.
Yep.
For those of our audience members who don't know what C. elegans is, it's a little tiny primitive worm that has such a simple brain structure that it turns out to be a great laboratory to use to study individual neurons or synapses in small quantities. C. elegans. Look it up.
Yeah, and I've heard that like people have been trying to figure out like how the neurons like we know where all their neurons are and how they're connected, but not how they actually like work compared to each other. And so the what I was reading was people are looking at like using calcium ions and seeing how those go in and out of the neural cells, and trying to like build up a model that'll help us be able to essentially have a worm brain in a computer. And we're like not even 20% of the way there yet, but
Wow.
it's happening.
Yeah, so it's incredible. I mean, scientists have spent decades trying to map out the 212 neurons and their connections in the C. elegans brain, and we still don't fully understand how even just that small pocket of neurons, their behavior gives rise to very simple behaviors in the worm. So yeah, it's we're still a far cry away from understanding the complexity of the human brain, which is orders of magnitude
Oh,
larger and
you
more
said more than a
complex.
billion. Yeah, more than a
More than a
billion
billion
neurons per
neurons,
brain.
yeah,
And
compared
so,
to
Man.
yeah,
212.
right. So, and more than trillions of synapses, the connections between the neurons. And like the Milky Way galaxy itself doesn't even have a trillion stars in it. So, in a sense, the human brain is more complicated in certain ways in its connections and its structures than even the galaxy we live in. So
Well,
the
we're in
cos
the galaxy, so I guess if you
right,
count us in the galaxy,
yeah,
but
and
yeah,
so the
Galaxies and galaxies, I think.
right. The
yeah,
irony really is, yeah, we have a complexity on our terrestrial scale
yeah,
which rivals the complexity of the entire galaxy itself. And it's so neat to see all these different things at all these different scales going forward. And it's no
yeah,
surprise to me at all that human brain and cosmic consciousness is all knit together and having a good time. Uh, Let me just ask one more question. I know we're running so low on time. I wish we could talk all night, but I know you're busy. You have a company to run. Uh, so, should I freeze my brain when I die?
Interesting question.
Hmm.
I would say right now we do not have the technology to reanimate someone later. There are folks who think
Oh.
that eventually we will develop the technology to take someone who has been frozen and reanimate them. I think that's very unlikely,
Okay.
especially for the brain.
Mm.
Okay.
So much of what we've talked about today has been this incredible complexity.
Yeah.
And
Mhm.
it's very hard to imagine that we may someday be able to take a brain that has been frozen and is totally not active at all and somehow
Mhm.
reactivate it, because there's such
Okay.
an incredible complexity of electrical and chemical signaling in the brain that sort of starting
Mm.
from something frozen and thinking that you're going to recreate those patterns is a little hard to imagine. I won't say it's impossible, but I think
What
Right.
do
we're
you have to
far,
lose,
far
though,
ways from
right?
that.
What do
Like
you have to lose?
you're going
Hmm.
to be dead either way. So if he has like if it's like a 3% chance, that's still pretty good.
Oh, yeah,
You
yeah.
never know.
I, I guess maybe my thought was that they may not be able to reanimate my brain if it's frozen. But if it's frozen really well, maybe it'll capture at one moment in time all of the synapses and all of the structures that exist at that point. And if we do have enough computational power to load up all those trillions upon trillions of synapses and connections, maybe they can get some sort of facsimile of what my brain was at that time. And therefore, maybe some piece of me that otherwise would be intangible might be tangible again. Any thought about that? Any possibility? Oh, tell me maybe. Tell me
that's
maybe.
that's such an interesting thought. Yeah, I mean, I suppose it might be possible. I think so much of what makes us who we are is not the snapshot in time, but actually how things change and
Yeah.
how your
Ah.
brain is changing on millisecond timescales, right? So much of
Mm.
what gives rise to your thoughts and emotions are continuous ongoing rhythms of activity in the brain and how these different rhythms interact with one another and changes in ions and voltages. And so even if you had a really pristine snapshot in time, I'm
Mhm.
not sure that you could recreate something that would capture much of who you are. Maybe.
Mm.
There's certainly a lot of information contained in just the structure and the connections and all of that. So it might be possible someday with some computational work and try to think about like mapping out all the connections in your brain and then maybe using a computer to attempt to like play the strings on your brain
Yeah.
structure
Try
there
and
and see if you could reanimate
reverse
it.
figure out. Yeah.
Are, are modern supercomputers even close to being able to do something like that?
Yeah, so it's a very interesting question. So what we have for some supercomputers and computers today, they compute very, very differently than the human brain. So it's really
Hmm.
interesting because computers are really good at doing certain things like math and binary logic and computation, and
Yeah.
there are certain things that supercomputers are way better at than the human brain. And then the flip side is also true. So
Mm.
the human brain, one of the things that makes us so interesting and unique is our ability to be so creative and come up with interesting, unusual solutions to things and to have so much variability. And computers are
Yeah.
really not good at recapitulating that. Computers have very strict rules, they follow those strict rules. And I think so much of what gives rise to who we are as people is our brain's ability to be so flexible and kind of unpredictable sometimes and
Mm.
creative. And that is something that's been very difficult to get computers to try and recreate.
Well, that's what they're working on it with the machine learning things, everything that we were talking about earlier.
Mm.
Yeah,
Wow.
exactly.
It's
Oh, the
there.
irony, right?
Yeah, I haven't gotten to our level yet on that, but
That the very thing that makes us human is the chaos in our brains that machines could never reproduce. How
I,
about
Exactly.
that?
I wouldn't say never, but haven't reproduced.
Pretty amazing. Dr. Nikki Driscoll, it has been such a pleasure to have you. We have barely scratched the surface on this topic and all the other cool things that you do. Can we have you back again sometime? Would love to have you back again sometime. Would that
Would
be all
love to
right?
join you again. This was a lot of fun.
Oh, thank you.
Awesome.
Thank you so much. Is there a way that we can be in touch with the things that you're doing? Keep up with the latest that you're involved with, social media or some website or uh, corporate card? I don't know. What? How can we stay in touch with the things that you're doing?
Yeah. I mean, we don't have too much social media, but we are on LinkedIn. So I guess the best way to follow along with what we're doing at Neurobionics is to check us out on LinkedIn, and we'll post updates there every once in a while when we are doing exciting things and moving forward.
Wonderful. Can't wait. Nicki, thank you again. Really, really appreciate your being here. Thanks so much for joining us today.
Thank you. It was a great conversation. A lot of fun.
Allen Liu, our co host, as always, thanks so much for everything.
Yeah, you're welcome.
And for all of you out there, thank you so much for being with us today. If you like what you see and hear, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.